Alright class, today we're going to talk about factoring 3x1s or 1x3s and how to solve using ZPP, kind of like what we did with chapter 5. So first things first, just some factoring. If you look at this, we have an x squared plus 6x plus 9. Hopefully you see that this is factorable by itself. This is a 3x1. This y term we're not going to touch yet. If you factor this, you get x plus 3 quantity squared minus 49 y squared. So now look at the thing we have. We have this quantity being squared, and we have this is a perfect square as well, because you could take the square root of this number. So now we have the difference of two things being squared. So we can use our difference of two squares pattern and say we have x plus 3 plus 7y and x plus 3 minus 7y. And that's our final answer. Alright, so on number 2, it's very similar except for the fact that we have to pull a negative out to make this factorable. So the first step is, I'm going to rewrite this, and this is a 1/3 because the x term is first. I'm pulling the negative out of these three things. This becomes a positive y squared, this becomes a minus 12y, this becomes a positive 36. Now this is factorable. So we have 9x squared minus the quantity of y minus 6 squared. And now I have, again, the difference of two squares. This is a perfect square, this is a perfect square. So I can say it's 3x plus y minus 6 and 3x minus y minus 6. Now be careful with that. If I do minus y minus 6, that becomes minus y plus 6 when you distribute the negative in. So this is the final answer, as is this on the first one. Okay, so that's how you factor a 3x1 or a 1/3. We have one more. Again, we have a 1/3. This is a perfect square again, so we have b squared minus 25 all squared plus a squared. Now, do I have a difference of two squares here? No, I do not, because there is no subtraction sign. So we can't do anything between these, but what we can do is we can do the difference of two squares just for the b squared minus 25. So next step, we have a squared plus b minus 5 and b plus 5. That's just the difference of two squares again, right here. Quantity squared. And then to finally simplify it, we could just say that it's the quantity b minus 5 squared times the quantity of b plus 5 squared. And that is how you would factor that 3x1. Okay. There's probably only one or two questions like that on the test and quiz, so just make sure you factor the one side first and then do a difference of squares if possible. Now, find all real roots. This is basically, we're solving now. Find all the zeros, find all the answers. And I'm asking for the real ones, not the imaginary ones. So first things first, we need to factor this. Again, this looks like something like grouping, because we have an x cubed, x squared, x, and a number. So try to group, factor by grouping. See if you can pull out anything in the front and then the back. So here we can pull out an x squared. Here I could pull out a 7, and I'm left with x plus 4. So right away, this can be factored by grouping, because we have the same term left when we pulled out our GCF. So I have the quantities x squared plus 7 and x plus 4 equal to 0. Guys, another thing. When you are solving, you need to keep bringing your 0 down. Okay? Don't drop the equal 0. If you drop it, it's not an equation anymore, and then it is not right, technically. So I will be taking a point off if you do that. Make sure you do not do that. Alright, next, we set each piece equal to 0. So we get x is negative 4, and then we get x is plus or minus. The square root of negative 7 is I root 7. But is that a real root? No, it's not. So technically, I do not want that. So we cross that out. The only answer I want is x is equal to negative 4. And that makes sense that we got 3 answers, 1 real, 2 imaginary, because we have 3 to the third power. It's a cubic function. So, all right, let's look at the next one. Number 5. Again, we're finding real roots, so we have to factor and solve. First, I pull the GCF out. It looks like I can pull a 2 and an x out, and that means I'm left with a 3x squared minus 7x plus 3 equal to 0. I have 2x is equal to 0, so x is equal to 0. And then I have to deal with this. Now, this one here is not factorable, because 3 times 1 is 9. There's no two numbers that multiply to 9 that add to negative 7. So, we have to use the quadratic formula to solve this. So, x equals opposite b, so plus 7, plus or minus the square root of b squared, which is 49, minus 4 times 3 times 3, 4 times 3 times 3, all over 2 times 3. Okay, so my answers are x equals 0 and x equals 7 plus or minus the square root of 13 over 6. You can't simplify that at all, and those are real answers. There's no I involved, so these count. Just because they're irrational does not matter. I only asked for real numbers. So, number 6, do not, I repeat, do not tell me my answer is 4 and that's it, because that is very wrong. Yes, 4 is one of the answers, and you can do that by taking the cube root and getting that. However, there are 2 imaginary answers that happen here. And notice on number 6 it says solve over the set of complex numbers. So now I want all the possible solutions, including the imaginary ones. So in order to do that, instead of just dividing or taking the cube root for the real answer, we need to also get the imaginary by factoring. In order to factor, we have to get it equal to 0. So I have x cubed minus 64 is equal to 0. This is the difference of 2 cubes. You need to know that formula. My a value is x. I'm going to just write out my a value, and my b value is 4. So it is a minus b, so it's x minus 4, and then it's a squared, which is x squared, plus x times 4, so 4x, plus 4 times 4, which is 16, or b squared, equal to 0. So now I can say x minus 4 equals 0, and x equals 4. And then this, right away, whenever you do the difference or sum of 2 cubes, you have to use quadratic formula, or completing the square for this actually, whatever one you want to use. This one you could actually use completing the square, because it's kind of nice to do that. I'm going to move the 16 over. So half of 4 is 2. 2 times 2 is 4. So I'm going to add a 4 on this side, add a 4 on this side. So, oh, but I should make this a negative 16 when I moved it over. So that should be a negative over there. And then when you rewrite it as a square of a binomial, it's x plus 2 quantity squared is equal to negative 12. Now we can take the square root of negative 12, and you get x plus 2 is equal to plus or minus, and then the square root of 12 is 2 root 3, but since it's a negative 12, it's 2I root 3. And finally, we move the 2 over, so x equals negative 2, because we subtracted to go over, plus or minus 2I root 3. If you use the quadratic formula, you should get the same exact answer. I just chose to use completing the square there to remind you that you can solve by completing the square. So my 3 answers are 4, which is my real solution, and my 2 imaginary solutions are negative 2 plus 2I root 3 and negative 2 minus 2I root 3. Alright, last one. Let's do, again, we need to factor. First off, though, before we factor, we need to get it equal to 0. That's the first step. So I have 3x to the 4th minus 54x squared plus 12x squared minus 216 equals 0. Now this could be another grouping one. So let's see if grouping works, because we have 4 terms. We'll take out of those and we'll take out of those. We can take a 3 and an x squared out, and we're left with x squared minus 18. Plus, we can take a 12 out, and that's it. And then we get x squared minus 18, which is what you should get. Make sure to bring the equal 0 down. Now we are going to write them as factors. And now we're going to set each piece equal to 0. So 3x squared plus 12 equals 0. Now if I wanted to factor this more, I could pull a 3 out and then just set that equal to 0. But it doesn't matter when you're solving, because now I'm going to solve it and the 3 will take care of itself. So you get x squared equals negative 4. So when you take the square root, x is equal to plus or minus 2i. That's 2 of the answers right there. Let's do the other one. X squared minus 18 is equal to 0. X squared is equal to 18. X is equal to plus or minus 3 root 2. So I got 4 solutions because I have an x to the 4th. And notice that 2 of them are real, 2 of them are imaginary, 4 total. And I want all of them, because I'm asking for number 6 and number 7, all the complex solutions, which means basically everything, versus number 5 and 4, where I'm asking for the real roots. The real roots means no imaginary. So be careful with that. Okay, and that will be all.